Yeah, YouTubers, Tazman here, bringing you another episode of Taz Teaches Java. And in the last episode, we went pretty in depth on references and how when you pass an object or look at copy object components, or if you try and access an object directly, you just get the reference to the memory location of that object. So in this episode, we're going to talk about a little bit more about classes. So I think I'm going to need another folder. We're going to call this Constructors, and we kind of talked just a little bit about this. Constructors. Constructors. All right. Oh, whoops! I didn't want that. Oh well. No, we got to get rid of you. I wanted that to be another package. So go ahead and say okay. All right. So we're going to do constructors. So new package. Constructors. Constructors. And what we're going to do is, what should I do? Go into our constructors here, and it didn't put it inside there because we didn't actually have the classes first. Okay, so let's just call our class constructor. So do new class constructor, Constructor. So we have our class constructor, and we're going to have, so this will be our main. So we hit tab here and type main. Like a show, and then we wait for it to update. There we go. Put a couple carriage returns in there. Then we're going to have one, and I think for my demo, let's just call it maybe dice. Yeah, let's do dice for now. So updates are available. We'll do that later. So let's go ahead and create one more one more class. I'm going to call it dice, D-I-C. Just kind of for explaining this. So let's say, for example, what a constructor is when you create a new object using the new keyword, you are invoking a hidden feature in Java or a hidden component of your class. So anytime you do this, it's actually creating a default constructor. And a constructor looks nothing more like public, public, and the name of the class. And unlike methods, you actually have this be exactly the name of the class, uppercase and everything. Not ice, I meant dice. So just like that, then it's blank like that, and then it looks. So this is a default constructor, and what it does is and Java creates this, or the compiler automatically creates this when it sees that there is a new class. It automatically creates this, unless the only time it doesn't is if you have some kind of constructor already created. So right now, if I said this is a constructor, and it receives input of, let's say, an integer called sides, how many sides the dice have, then no longer will it be able to invoke the default constructor, which would look like dice, my die, maybe 8 equals new dice. And if I try and do this without anything in it, now it's complaining because there is no default constructor, because I've created one. So if I want to have one that allows just a blank, then I also have to create a second one here. Dice, public, dice, and then just parentheses. Oops. I like that. And now it'll be happy just having a plain one. So when you have a default constructor, what it does is basically the default one does nothing more than initialize all your different variables inside your thing. So for example, we were to say maybe let's say we wanted to say we have dice here, and we're going to say private int and sides. So how many sides the dice has, right? Because we're not initializing it here, the default constructor, when this object is created, will automatically create that for us, and it will initialize it for us. Now, what it does is if it's a numeric field such as an integer, it will set it to 0. If it's a double, it'll actually be 0.00, float, long, short. All those that are integer types will actually be set to a 0 value. If it's a character, if it's a char, not a car, a char. If it's a char, it will, so let's just do this. So any integer will actually set it to 0. Or actually, I don't want to do that. Let's say it will, so default default constructor sets all numeric values to to 0 or the decimal version of 0.00 or something like that, or 0.0, I don't know. Then if we have a char, I don't know what we'd use a char for with dice, but let's say char color code or something, COL color code. A default constructor would set this, because it's a char type, would actually set this to, it would be with a single tick and a backslash and the letter U and then 4 zeros. So that's the default value for that. Then any booleans, like boolean, boola. So a boolean of is, I don't know, rolled. Any of those would automatically be set to false. And let's see, strings. So str string. Brand or something, I don't know, brand. So like a brand of dice, I guess. All strings would be set to a blank value like that, or they might also be null like that. And I think, is it uppercase N-U? No, N-U-L-L. Yeah, I think it's all lowercase. So it would be set to null, which is a no value. And then objects and stuff will be set to null or empty as well. So I think that pretty much covers it, because strings are objects, so they'll either be set to null. That means arrays would be set to null until you put in a value saying, okay, but I want all of them to be this value, this value, this value. So now we have a couple constructors, and this kind of leads us into our what's called overriding. So if, let's say, I don't want to get rid of these, because if I put this stuff up for you guys to look at later, I want you to see the info. So we'll just comment it out instead. We'll pretend it's not there. So right now all we have is this sides, right? And this side's here. Well, so for our default constructor, in this case, where sides is the name of this and sides is here, the way we distinguish that we want the classes sides and not the local variable for this default constructor or method is we use this keyword, and we do have to spell it right. So this is referring to the constructor's sides, which is the this, and then now you don't need this. Like if this was called something else, like how many sides, then we could actually just say sides. Now, in order for this to work, like if we wanted a default set sides, so this is if we want the person to say how many sides is on a dice. If we wanted a default value whenever this is launched, we could also say side, S-I-D, what am I thinking? S-I-D-E-S, sides equals 6, right? So now if I create a dice down here, like my die right here, and we don't have anything in there, and then we create another one, dice, and we'll call this my die 2. Oh boy, I can't type today at all. New D-I-C-E, and we actually pass this one. Let's say it's a 8-sided dice. Oops, 8-sided dice, right? So what this is going to do is, because it detects this is an integer, it will go and look at the definition for it, and it'll say, oh, this one doesn't require anything. It's not looking for anything. This one, of course, is looking for something. We could also do the same thing, even though it's another number value. We could actually say, you know, Control V. This is going to complain because we're already using int, right? So we could say long or something like this. L-O-N. Oh my gosh, I can't type today. Long. And then it will be able to do it. Now this isn't going to work because sides here is looking for an integer. So we'd actually have to have something else up here called like an L sides or something for long sides, because this is only expecting an integer. So here we're actually passing an integer also. But we could do those other type of things. So we're going to get rid of that. So now if we do these two, right now we're not going to be able to output anything because this is a private, its access modifier is set to private, which means we can't access that unless we have a setter getter, or a getter in this case. So we could say public, public, and we could say void because we don't need it to return it. We just want it to output it, right? So we're going to say get SID sides. So we do that. We don't need it to pass any parameters, and then all we have to do is oh no, we don't want to return because we're not returning anything. We're just going to go say s out, s. Boy, I should not be typing today. S out, and then we'll do let's do this, SIDES, and we've jumped into our overwrite mode and do colon and that, and then say plus SIDES, and then we just have our close and that. So now if we want to look at this and we want to say, okay, well, here we did the default constructor with nothing in it. So if we follow this through, we see that it's going to actually set it to sides equals 6. This one is going to set sides to whatever we set it to. So in this case, it's going to be 8. So if we say get, or whoops, we need my die dot get and sides. And then we can also do my die 2 and dot get sides. So like that. Now if we run this, save, and then run, you'll see we'll get one that says side 6, one that says sides 8. Now another way we can do this, because this can get a little sloppy, especially if we have lots of these type of constructors. Maybe we have something that does the sides and how many dice as a third thing. So let's actually right up here, let's just create another one that takes on a second value, right? So we could say this sides and let's say comma int how many, right? So for how many dice we want, and then we want to have up here, for example, private private int how many, and set that like that. So this means now I actually have to come in here because I want to have a how many, and let's say the default of how many, we would say how many equals 1. So if I don't give it any parameters, it's going to create a single 6-sided dice. In this case, it's going to create, because we're not passing how many again, so it's going to create a how many equals 1. because that's just going to be our default. If we actually want it to create a specified amount, then we would do this and say this dot how many equals how many, right? And this will make it so that it creates a dice of however many we want. So you'll notice something, that we're seeing a lot of redundancy. We're getting how many twice here. And if you keep imagining, you know, that we're going to add other fields. For example, maybe this is a car, and we might say miles per gallon, and then we might say how far it's traveled, or what its odometer is at, or how full the tank is. And we can have all these different ones. Well, this could be pretty hectic after a while to keep track of, because then, oh, if I want to change the default, now I have to change this to 2, I have to go change this to 2, I have to go change all of them to 2. So one thing we can also do to make this a little easier is we can actually invoke a next method or another constructor from a constructor. So what we could do here instead is say, let's just get rid of, let's just get rid of this. And we're going to say this, in parentheses, whoops, this, our parentheses, and inside the parentheses, we're going to stick in that default value that we were setting in here, right? We had a 6. Now we don't have to worry about the how many, because we're actually setting that here. Then we can do the exact same thing here. We can say, right here, we can say parenthesis, and we want sides to be whatever it's set. In this case, this is going to invoke it, and it's going to pass 6. So now sides will have a 6 in there. However, we're not setting the how many, so we want to set a 1. And now we can get rid of this how many. Then we do the exact same thing over here, because now we're passing sides and 1, so we're passing the sides the user wants, and we're leaving the default to 1 for how many. And here is where we actually would set our different values. So as you can see, it's quite a bit less typing. And this way, if we want to change the default of how many sides or the default dice, if we wanted to change this to, say, a 20-sided dice, right? Now, whenever someone invokes the default class, it will always create a 20-sided dice, and it's just a single one because everything's set up here. So if we create one more of these, a setter getter, actually, let's just do this. Let's just do get info. We'll change this to info. And we'll say sides equals this, and then a plus, and then a quote, and that. Maybe do 2, and say how many, and equals plus how many. Whoops, didn't mean to do that. We just changed our thing. Where's the reset appearance? I think I won't worry about it right now. We can get it back just by clicking on our package explorer, and I think restore. There we go. We also had the one down here, but I'm not worried about that right now. So anyway, now we can do how many, control space, so like that. And when we do this, now you'll see that these aren't happy because we changed it to info. And info. And let's go ahead, and we got rid of we got back into our overwrite mode. Then, oh, whoops, we need parentheses here and here. And let's go ahead and we'll just create a third one where we're actually setting, oh my gosh, I'm batting 0 today. So do that. We'll call this my dice 3. And we're actually going to say, so we set the default to 20, so this is going to be 8. This, let's say, is maybe a 4-sided dice, and we're rolling 4 of them. Okay, so as you can see, all these constructors are actually valid, and this constructor will call this constructor. Now we could actually, if we had this also have the sides in there, if we put in 1 in there, it would automatically call this one because it's just looking for the constructor that matches this definition, which is the constructor name with a single integer in it. So this one expects 2 integers. This one has a single integer, so it passes it there. This one, on the other hand, is looking for an integer and an integer, so it's going to invoke that one. Hopefully that makes sense to you. So then we're going to go ahead, get info. I didn't do an uppercase I. And let's just do another one for 3. C and V. And this will be number 3. So if we run this, we'll see that everything is running super nice again. And I hid my... Let's go ahead and restore this guy too. So as you can see here, 6 and 8. Oh, wait a minute. Might I too? Did I change something? 6 and 8. Is that what we set it to? 6 and 4. No, I don't think it ran right. There we go. Now it's running. So you can see sides is 20 on the first one and 1 die because we didn't set any values. These are the defaults. So here we do set the 8, but we don't set the how many, so that goes to the default. Here we're setting both, so we actually get both. So this makes it a little bit easier to be able to maintain, because if I want to change the default, then I only have to change it in one place, where before I'd have to change it multiple places. So hopefully that makes a little sense. Let's go ahead and talk. I have some verbiage here I just wanted to read really quick that I wrote down. So a constructor initializes an object when it is created. It has the same name as the class as we did here. It's dice, and that's dice. So it has the same name as the class and is syntactically similar to a method. However, constructors do not have a return type. They don't have any explicit return type. I can't even talk. Typically, you'll want to use a constructor to give an initial value to the instance of a variable defined by the class, or perform any other startup procedures required to create a fully formed object. All classes have constructors, whether you define one or not, because Java automatically provides a default constructor that initializes all member variables to their default values, and we talked about those. However, once you define your own constructor, the default constructor is no longer used. So if we forgot to do this one, if we did a blank one, we would never, it would error out, it would give us an error. We always have to, if we create this and there's a chance we want the default one, we have to add it ourselves. Then it is possible to define a method that will be called just before an object's final destruction. So there's also, with constructor, there's also something called finalize, or a finalizer, or something like that. And it's similar to a constructor. However, there's really no reason, there's rarely a reason you would want it. But to invoke the finalizer, so this is the constructor, it constructs things. The finalizer, or finalize, is a destructor. It basically tears apart an object and cleans up memory. But we have the garbage collector, which does a pretty decent job. So the finalize is called when the object is destroyed, or when it's no longer going to be used. However, the garbage collector will do that same thing, and there's no guarantee that while your program's running that finalizer will actually be called. So it's more of a possibility. So we could do PROTECTE. So it's protected, void, and finalize. Finalize E, and then your parentheses, and then anything you wanted in here to call when you finalize. So this might be like if you had the scanner open, SC, what I usually call it, you could invoke the close here, like so, and it would close the finalize. It would close the scanner. Usually we just call that the end of our program. So this would be FINAL, finalization. Code goes here. And I'm just going to say, so this is our constructor up there. So I'm just going to say final, final, I-Z-E, finalize. And in parentheses, I'm going to do decon, structor. But like I said, for the majority of your purposes, you really don't even need this. So let me just finish reading what it says about it, because it's actually going to say kind of what I just said. So it is possible to define a method that will be called just before an object's final destruction by the garbage collector. This method is called finalize, and it can be used to ensure that an object terminates cleanly. For example, you might finalize to make sure that an open file owned by that object is closed. To add finalizer to a class, you simply define the finalize method. The Java runtime system calls that method whenever it's about to recycle an object of that class. Inside the finalize method, you specify those actions that must be performed before an object is destroyed. And then there's the structure of it. It is important to understand that finalize is called just before garbage collection. It is not called on an object when it goes out of scope. For example, this means that you cannot know when or even if the finalize will be executed. Oh, I need for example here. For example, if your program ends before the garbage collector occurs, finalize will not execute. Therefore, it should be used as a backup procedure to ensure the proper handling of some resource, or for this special use, or for special use applications, not as a means, not as the means that your program uses it its normal operation. In short, finalize is a specialized method that is seldom needed by most programs. So this right here, what we did, this is called constructor chaining. And that's because we're chaining this one to this one and this one to this one. The other way we had it is just basically a bunch of constructors. Now, I wanted to talk a little bit about, thinking if we want another, oh, this is the wrong one. I wanted this guy. This guy will actually show everything. No, not this guy. This guy. That guy's the one I wanted. Another thing I kind of want to talk about is, we talked about before the subclass and the superclass, right? And the superclass, we extend our thing into it. So we're going to do a quick little example of that. So we're at 20 minutes. Okay, we should be able to do this. I really wanted to get to it. So we're going to create a new one, and maybe we'll just call it superclass. So we need a new package. Now the reason that, remember how I had to move constructors? It's because right now it's in classes. I needed to do this and just then type constructors here. SUPERCLASS. Superclass. So what we're going to do for this, now you'll see it actually formed inside there. I'm going to create 3 classes in here. We're going to have one called person. I'm going to have one called student. And we're going to have one called, what should I call it? Person. Oh, I want, and then let's just call it test. This will be the one that has our main in it. So this will be called test. This is testing our stuff to show you it. So to start off, all students are people, but all people are not necessarily students. So that would mean that the student needs to extend the teacher, or the person class, sorry, not the teacher. So that's the first thing we're going to do here. We're going to extend, and this has to do with, remember we were talking about inheritance, and we're going to say person. which means that this student extends. This student basically has all the same stuff the teacher or the person does, plus its own other things. So let's go ahead and do that. And then we're not going to do anything real special. We're just going to have in here our constructor. So let's say this is our class student, and we're going to have our constructor, which is going to be PUBB public, and we'll just call it student because it has to be called student. It's the constructor. Now what we're going to do here is we're going to invoke the person class, right? Because we're going to do it through what our superclass is. So, and the way we do that is and let's just say invoke or call, I guess, the parent class or the superclass. The P-A-R-E-E-N-T parent or superclass. Okay, and then all we have to do this is type super in parentheses. SU super with parentheses. So when we invoke a student using its constructor, it's going to invoke the super constructor, or it's going to invoke the constructor of person, which is its super, right? Now, one thing I don't think I mentioned, maybe I did, but with our constructor before, this command has to be the first executable command after the constructor, just like in our other one, constructors, just like in dice here, this where we're invoking this, it needs to be first. If we had other things in here, that's fine and dandy, but this needs to be the first thing that's an actual command that needs to run for it to work properly. So we're invoking our super, and then just to let us know when we get back here, we're going to do sout, and we're going to say that this is the student class constructor. Student. So this will be our student class constructor being called. Why are you red? Oh, maybe it's not even, it doesn't even like having the comment above it. I thought it did personally, but okay. Whoops, delete. And what else we got here? Why are you red? P-U-B-L-I-C. Student extends person. Do I not need the public? All right, we'll just try that. Maybe as we go on, it'll be more picky or something. I don't know. So yeah, I guess even a comment can't go above it. It expects this super to be right underneath the constructor's beginning. So let's go into person now, and let's create that one. The person constructor, all we're going to do is say tab. Oh, did I have an uppercase? Maybe that's what it was. P-U-B-L-I-C, public, and person. Or it might be because I was extending. I'm not sure. We'll experiment with it. And all this is going to do is do an sout. And it's going to tell us that it's in the PER as a person, class, constructor. I just want to double check. Is it because... Oh, I know why we were doing... No. Was it here? P-U-B-O-I-C. I think I had it uppercase. I'm not sure. So here we have our student, which is going to invoke the person. This would be for, initializing we needed here. You can also, like, if I had, for example, taxes, and I had like a net pay that I pass in, or gross pay, and I want to know the net pay, then I can actually have this do that on start or whatever. So there's our student. I think that is all we need for that. So the last thing we need is just our test. This is going to have our main. And let's go ahead and say student, because we're going to create a student. We'll just call it S, and we'll say equals new nerd, a nerd student. So as you can see here, we're not invoking the person constructor. We're only invoking the student one, but the student one is invoking its superclass, which is person. So if we run this, we see it will say, it'll say person class constructor, and then it'll say student class constructor. And it helps more if we are, sometimes Eclipse can be a little bit finicky. So as you can see here, person class constructor, student class constructor. So this is your superclass and subclass inside of your program. So maybe, I'm trying to think of when we want to call it good enough on the learning part. I mean, we still have things like the, I can't think what it's called now. Not includes implements, where we implement our what are they called? If I do this, I can always see what it's called. It's called interface. So we have interfaces we can do implements on, and you can have as many of those. And an interface, which we'll have to go over, is basically kind of like a contract or something that says anything that implements what I say has to contain the functions that I contain. And it's basically just the function definition. So maybe we'll go over that in the next episode. And then I think we might be pretty much ready to do some challenges and do some programs. So I hope you guys enjoyed this episode. Hopefully it wasn't too confusing for you and it made a little bit of sense. We did cover quite a bit with constructors and superclasses. Let me know what you think down in the comments below. Aside from that, leave a like if you enjoyed it. Aside from that, comment, like, and subscribe. Follow me on Twitter. Check out my Discord if you want to be notified of when I am uploading videos. Next to the sub button, the subscribe button, you can click the little notification bell and tell it to notify you. Also, if you're following me on Twitter, you'll be able to get that same notification through Twitter. But that's it. Until next time, I'll be seeing you later. Bye.